It was a quiet summer evening in 1977 at the Ohio State University's Big Ear radio telescope. The Big Ear, as it was affectionately called, was a massive fixed installation spread out like an open book across the Ohio countryside. Its metallic surface gleamed faintly under the fading light of the setting sun, and it stood silently, its only function to listen to gather radio waves from the depths of the cosmos. There were no blinking lights, no sophisticated screens, and no computer alerts. Instead, it was all printed on long sheets of paper, a steady stream of alphanumeric data fed out by the observatory's primitive computing system. Most of it was routine background noise, harmless, predictable, and unremarkable. But on August 15th, something happened. Something that would haunt and puzzle scientists for decades. Among the researchers working with the telescope's data was Dr. Jerry Emin, a volunteer with the SETI project Search for Extraterrestrial Intelligence. His job was to sift through those endless printouts, looking for anomalies, for patterns that might hint at something extraordinary. He had seen thousands of rows of data by then, but that night, as he glanced across the sheet, his eyes were drawn to a strange sequence, 6EQUJ5. It wasn't just unusual, it was stunning. The values corresponded to a very strong signal, stronger than anything they'd seen before. It followed the precise curve expected from a narrow bandwidth transmission, rising in intensity, peaking, and then fading, matching the telescope's 72-second scan window exactly. His heart pounding, Jerry reached for a red pen and circled the sequence beside it. He wrote one word: wow. That redinct wow would immortalize the signal and define the mystery that followed. From that moment forward, it would be known not by its technical designation, but as the wow signal. The strength and clarity of the signal were unprecedented, more than 30 times more powerful than background noise. But what truly set it apart was its frequency, 1420.456 MHz. That wasn't just any frequency, it was the hydrogen line. Neutral hydrogen atoms naturally emit radiation at 1420 MHz, and because hydrogen is the most abundant element in the universe, scientists long believed that any advanced civilization trying to send a message across the stars would choose this frequency as a universal standard. It's quiet, clean, and logically a cosmic calling card. Earth-based transmitters are forbidden from using it. The signal, in short, came from a band of the radio spectrum where only the universe is allowed to speak. And speak it did once, and only once. The Big Ear picked up the signal for a full 72 seconds, and then it was gone. The telescope, mounted on a fixed structure, relied on Earth's rotation to sweep across the sky. As the observatory slowly moved past the signal's source, the signal peaked and faded exactly as expected. But the real mystery came afterward. In the days and weeks that followed, astronomers aimed the Big Ear back at the same region of the sky again and again. Other observatories joined in, but no signal ever came again, not a whisper, not a flicker, just silence. The signal appeared to come from the direction of the constellation Sagittarius, near the center of the Milky Way galaxy, but even that much remained uncertain. Because the Big Ear used to feed horns to detection points slightly offset, it wasn't possible to determine whether the signal came from the first or second horn's coverage area. This created two possible coordinates, just minutes apart, but both equally ambiguous. Neither location revealed any known stars or planetary systems that could explain such a signal. There were no nearby satellites, no Earth-originated sources, and no known celestial bodies that emitted in such a narrow and focused band. The implications were enormous. Scientists debated endlessly over whether this might finally be the first contact. If a civilization out there had deliberately sent a message, this is exactly what it would look like: short, strong, at a universal frequency, from deep space. And yet the very uniqueness of the event made it almost unusable scientifically. Science depends on replication. Without a repeat, even the most intriguing anomaly remains just that, an anomaly. Jerry Emin himself remained cautious. Though clearly amazed by what he had seen, he never claimed it was proof of extraterrestrial life. But he didn't dismiss it either. He simply couldn't explain it, and neither could anyone else. As the mystery deepened, theories emerged. Some suggested it was a natural phenomenon, reflection from space debris, a pulsar, or a rare burst from a distant star. But none of those matched the signal's shape, intensity, or narrow frequency. Others proposed terrestrial interference, perhaps a secret military transmission. But again, the frequency was one governments weren't allowed to use, and no terrestrial signal would have such a clean, precise Doppler curve. One of the most consistent explanations from SETI supporters was this: the signal was real, and it came from far beyond Earth. But if so, why only once? Was it a beacon, sent toward Earth on a fixed schedule, and we had missed the rest? Was it a roaming spacecraft, drifting through the galaxy and sending out bursts of communication? Or was it simply a mistaken, accidental leak of information from an alien source, not even aware we were listening? The wow signal was so brief, so perfect, and so unrepeatable, that it sits in a strange place between science and mystery, accepted as real, but unexplained. Over the years, many tried to chase the signal. The original paper printout still exists, kept as a historic artifact. The data was scrutinized by astronomers worldwide. New observatories were built. Sky surveys became more powerful, scanning millions of stars in far more detail than anything Big Ear could have imagined. But still, in all that time, nothing has matched the wow signal's power and precision. For scientists like Jerry Emin, who circled that number in red pen, the moment is frozen in time, a single spark in the silence of space. It was real, it was powerful, and it never came again. Perhaps most haunting of all is this: if the signal did come from an intelligent source, and if it was meant for us, we missed our moment. Maybe it was a handshake across the stars, sent across light years, and we were only barely listening. Perhaps that civilization has moved on, or gone silent, or even disappeared, and we were left with just 72 seconds of wonder, and a word scrawled in red ink. In the end, the wow signal remains one of the most profound and unsettling moments in the search for The wow signal wasn't just an unexpected blip on a graph, it was a scientific enigma that challenged everything astronomers thought they knew about the universe. Once the initial excitement settled, researchers began a deeper investigation into the signal's exact properties, trying to figure out what it truly meant. The intensity of the signal was undeniable. It peaked at over 30 times the background noise level, and its profile was clean and strong, unlike the scattered, fluctuating patterns caused by natural space phenomena. It was narrowband, meaning it was confined to a very specific frequency, unlike most natural emissions which spread across the spectrum. This alone was significant. In the radio astronomy world, narrowband signals are often considered a potential sign of artificial origin. Nature, as far as we know, doesn't typically create them, technology does. The frequency, 1420.456 MHz, was also impossible to ignore. It sat squarely on the hydrogen line, a frequency produced naturally by neutral hydrogen atoms, the most abundant element in the universe. This line is considered a kind of cosmic hailing channel, a frequency so obvious that scientists have long assumed that any intelligent civilization trying to communicate would use it. Earth's own transmitters are forbidden by international law from broadcasting on this frequency to avoid interference with space research. The wow signal's exact placement on this frequency made it not just scientifically fascinating, but symbolically profound. It seemed like the most logical place for a cosmic handshake, as astronomers delved deeper into the data. Another anomaly emerged. The signal had only been detected by one of Big Ear's to feed horns. Because of the telescope's unique structure, its twin receivers would each scan the same point in the sky, about 3 minutes apart. A real, persistent signal such as one from a satellite or space debris should have been detected by both horns. But this signal was only caught by one. This made triangulation difficult. There were now 2 possible points of origin in the sky, separated by just a few arc minutes, and neither contained any known object or obvious source. There were no bright stars, no exoplanets, no black holes or quasars, just empty, quiet space. The fact that the signal had not repeated baffled scientists. Dr. Jerry Emin and his colleagues pointed the Big Ear telescope at the coordinates repeatedly in the days that followed. Other observatories were notified. Nothing. Over and over again. Astronomers searched that section of sky, hoping to catch even a faint echo of what had happened. But the cosmos remained stubbornly silent. That silence spoke volumes. In the world of science, replication is everything. A result that cannot be repeated, cannot be studied, confirmed, or understood. The signal became a ghost, profoundly intriguing, but impossible to grasp. Some tried to explain the event away. Maybe it was a fluke. They said a signal from a passing satellite, a secret military transmission, or an echo off of space debris. But the deeper scientists looked, the less those answers made sense. For starters, the hydrogen line was a protected frequency. No known Earth-based technology transmits on it, and military communications don't operate in that range. The shape of the signal also didn't match the erratic patterns of bouncing signals or atmospheric interference. Its clean curve was precisely what scientists would expect from a signal originating far out in space and moving relative to Earth. It matched predictions. It followed the rules. That made it even stranger. The natural explanation theories also began to crumble. Pulsars, quasars, and other exotic celestial phenomena do emit radio waves, but they tend to do so across broad frequencies. The WOW signal was too focused, too narrow. It didn't match anything known. Some scientists proposed that perhaps the signal came from a rotating neutron star or a rare cosmic burst, but again these phenomena are loud and messy. They repeat, they scatter. The WOW signal was a whisper, and it came once. As years passed, the signal became more than a scientific puzzle. It became a symbol. It was used to justify further funding for SETI, to ignite public imagination, and to anchor philosophical discussions about humanity's place in the universe. People began to ask, if this wasn't aliens, then what was it? And if it was aliens, what did they want? Some SETI scientists proposed a romantic theory. The WOW signal was a ping, a short test pulse from a distant intelligence, just to see if someone out there was listening. A kind of, "Are you there?" sent across the stars. Others believed it may have been part of a much larger signaler, repeating sequence we only caught once. Perhaps the signal was directed toward us on a cycle of months, years, or even centuries, and we happened to intercept one moment. If so, it might return eventually, or it might not. Another possibility was equally chilling. We received the message, but we were never meant to understand it. Maybe the sender was gone, destroyed by war, climate, or time. Or perhaps they had moved on, shifting their transmissions to new frequencies or different methods entirely. The WOW signal could be a message in a bottle from a dead civilization, drifting through space with no one left to claim it. SETI teams remained hopeful. The decades that followed saw enormous advancements in radio astronomy. Telescopes became more sensitive, more powerful, and more automated. Data analysis moved from paper printouts to sophisticated algorithms, and yet, with all this progress, nothing has equaled the WOW signal. It remained the loudest, cleanest, and most tantalizing signal ever detected by the human race. What troubled researchers most was the completeness of the signal. It wasn't garbled or half lost. It was perfect. It had structure, duration, intensity, and direction. It looked like a deliberate transmission. Yet, despite this, it stood alone. For a single 72-second window, the universe opened its mouth and whispered, and then it went quiet. The WOW signal also reignited debates over the Fermi paradox, the contradiction between the high probability of extraterrestrial life and the total lack of contact with it. If the universe is teeming with intelligent civilizations, why haven't we heard from them? The WOW signal gave the paradox new weight. Perhaps we had heard from them once, and only once. For many, the signal became a kind of cosmic Rorschach test. Skeptics saw a technical anomaly or an error in interpretation. Optimists saw a distant intelligence reaching out. Philosophers saw a sign of our loneliness. For SETI, it was a guiding star, a mystery that justified the continued search. They began to dream bigger, launching multi-telescope arrays, global networks of listening stations, even citizen science projects, where ordinary people could join the hunt. Yet no one could answer the simplest question. What was the WOW signal? Not what it might mean, or what theories fit best, but what it actually was. It sat outside known science, resistant to explanation. Some mysteries give up their secrets over time. This one grew deeper. The more it was studied, the more profound its silence became. In 2012, 35 years after the signal was first recorded, a team revisited the original coordinates using modern telescopes. Again, nothing. The silence had become its own form of data, strange and stubborn. Confirmation that whatever happened in 1977 was unique. For Jerry Emin, now older and long retired, the memory of circling that red WOW remained After the initial discovery of the wow signal, the astronomy world was stunned. It wasn't just a scientific curiosity, it became an obsession. For the SETI community in particular, the signal represented something extraordinary. It was the single most promising candidate for contact with an extraterrestrial civilization, but it was also incomplete. No message, no code, no repetition, just a brief transmission lost in the background noise of the universe. And that was precisely what kept them searching. The late 1970s and early 1980s became a golden era of hope for SETI researchers. If the wow signal had occurred once, the logic followed that it could occur again, maybe in the same place, maybe somewhere else in the sky. It lit a fire in the community. Observatories all over the world began coordinating to rescan the region of Sagittarius where the signal had originated. Teams from Ohio State, Harvard, Puerto Rico's Arecibo Observatory, and Australia's Parkes Radio Telescope all took turns aiming their dishes at those same coordinates. For years, they listened, but the silence remained. Despite improved equipment and longer scans, no follow-up signal was ever detected. For some, it was a clear message. The signal was a fluke. For others, it was a challenge. The logic of the wow signal, narrowband, hydrogen line, intensity, and duration still held. If this was contact, it must have been deliberate. So why wouldn't it happen again? SETI leaders like Frank Drake, Jill Tarter, and Carl Sagan rallied support for deeper investigations. The signal reinforced what they had long argued, that we must listen patiently and broadly, not just for words or patterns, but for anything unusual. It inspired new projects, including the Billion-Channel Extraterrestrial Assay, the Allen Telescope Array, and Project Phoenix, all designed to monitor millions of stars across billions of frequencies. These weren't simply telescope missions, they were acts of faith. Every antenna pointed at the sky carried with it the memory of that one perfect signal. In 1985, SETI launched one of its most ambitious undertakings, META, the Megacanal Extraterrestrial Assay. Using computers that scanned over 8 million channels, META aimed to catalog and identify narrowband signals that might indicate alien technologies. It was a monumental effort, and again, the wow signal was a model. The project was designed specifically to detect signals with similar characteristics: clean, narrow, unmodulated, and within a certain frequency range. But once again, nothing matched the wow profile. There were candidates, false positives, and fleeting spikes, but nothing with that same haunting intensity. And so, the signal grew legendary. In science circles, it became a kind of benchmark, the bar that any potential alien communication must reach to be taken seriously. In popular culture, it took on a mythic quality. Books, documentaries, and speculative essays exploded around it. The question lingered: had we missed our only chance? Still, researchers didn't give up. The rise of digital computing in the 1990s gave SETI a new tool: distributed processing. One of the most famous projects born from this era was SETI at Home. Launched in 1999, it allowed ordinary people to donate unused computing power from their home PCs to help analyze radio telescope data. Within months, SETI at Home had millions of users worldwide, all collectively sifting through signals from space. At the heart of this new global search was the same question that haunted the field for decades: could there be another wow signal hidden in the static? SETI at Home revolutionized public engagement. People weren't just watching the search anymore, they were part of it. Tens of thousands of eyes were metaphorically staring at the stars, hoping to be the first to catch the next whisper from the cosmos. It was crowdsourcing on a planetary scale, and it was powered by curiosity, wonder, and the unanswered question left behind in 1977. Despite the passion and scale, the results were consistent. Promising signals came and went, but nothing sustained, nothing repeated, and nothing captured the pristine clarity of the original wow event. Even as technology advanced, telescopes grew larger, and artificial intelligence entered the field. The silence held. Part of the problem was the nature of the search itself. The universe is unimaginably vast, and the radio spectrum even more so. Searching for a single signal from an unknown source on an unknown frequency at an unknown time is the very definition of a needle in a cosmic haystack. If the wow signal was indeed intentional, it may have been a single pulse, part of a longer series we missed, or even an automated beacon from a long-dormant probe. There's no way to know, and that's what kept people listening. In the 2000s and 2010s, CETA's mission evolved. They began to explore other forms of communication, optical SETI, looking for laser pulses, infrared searches, and even gravitational wave monitoring. Yet no matter the method, the goal remained the same: find another signal like the one in 1977. The wow signal was the high watermark. Everything else was just noise. A key moment came in 2015 with the announcement of the Breakthrough Listen initiative. Funded by Russian billionaire Yuri Milner and supported by Stephen Hawking, this $100 million project aimed to survey over 1 million stars and 100 galaxies for signs of intelligent life. It was the most comprehensive search in human history, and again, the guiding example was the wow signal. Researchers used it to model what an alien message might look like. They even rescanned the original coordinates with the most sensitive instruments ever deployed for such a mission. Still, the cosmos refused to speak. Despite the lack of confirmation, interest in the wow signal never faded. In fact, it only grew. Scientists began to appreciate it, not just as a possible alien transmission, but as a crucial moment in the history of our species. The moment we came closest to answering the age-old question, are we alone? The obsession wasn't limited to astronomers. Psychologists, philosophers, linguists, and theologians all weighed in on the meaning of a one-time cosmic signal. Some wondered if we even had the tools to interpret such a message, or if we'd recognize it, if it were coded differently, say, as a modulation of gravity, or a change in the cosmic microwave background. Others speculated that intelligent civilizations might deliberately avoid contact, choosing instead to watch us silently, a modern take on the zoo hypothesis, where Earth is a kind of protected preserve. But the wow signal stood apart, because it was real, not a theory, not a myth. It was documented, measured, and recorded, and no one could explain it. Over time, it became a mirror, not just reflecting the cosmos, but reflecting ourselves, our hope, our fear, our endless desire to not be alone. Even skeptics couldn't fully dismiss it. The standard explanation that the signal was an Earth-based transmission reflected off space debris was thin. It didn't align with the telescope's mechanics, nor did it explain the narrowband frequency. The explanation: by the early 2010s, more than 3 decades had passed since the wow signal lit up the feed from the Big Ear telescope. It had become something bigger than science, a cultural icon. For those who believed in the existence of intelligent life beyond Earth, it was the ultimate clue. For skeptics, it was a one-off anomaly blown out of proportion. But whether people believed or not, the signal refused to be forgotten. It stood on the edge of belief and data. And in that tension, something remarkable happened. The birth of modern extraterrestrial skepticism. The wow signal had been intensely studied, dissected, defended, and doubted. Some of the sharpest minds in science tried to explain it with terrestrial causes. Maybe it was a passing satellite, some said, except satellites don't transmit on the hydrogen line. Maybe it was military radar, but again, the frequency was protected. Some even suggested it was a bug in the system, but the Big Ear telescope was known for its reliability, and its dual-feed horns provided a natural check against system errors. Still, not everyone was convinced of its extraterrestrial origin. One of the most well-known attempts to explain the signal came from astronomer Antonio Parris, who in 2016 proposed a new theory. He suggested that the wow signal might have been caused by a pair of comets, 266P Christensen and P 2008 Y2 Gibbs, which were in the same area of the sky during the time of the signal. According to Parris, the hydrogen clouds surrounding these comets could have emitted radio waves at the 1420 MHz frequency as they passed. It was an intriguing idea, and Parris even conducted follow-up observations, but critics quickly pointed out flaws in his theory. The signal was too strong, too clean. A diffuse hydrogen cloud from a comet wouldn't produce such a tight and intense spike. More importantly, the Big Ear telescope should have detected similar signals from other comets if that were the case, but it never did. The comet theory fell short, but it did reignite interest in alternative explanations. It reminded the public that science welcomes doubt, but only the kind supported by evidence. Meanwhile, the believers held firm, not necessarily in the idea that the wow signal was proof of alien life, but but in the idea that it might be, and that such a possibility demands respect. Jerry Emin himself, the man who first circled WOW on that fateful printout, never claimed the signal was from aliens, but he also never ruled it out. For decades, he maintained a careful, scientific neutrality. "We don't know what it was," he often said in interviews. "We may never know." That humility is what gave the WOW signal such staying power. It wasn't proof, but it wasn't nonsense either. It was one of those rare scientific anomalies that sat perfectly balanced between wonder and doubt. And over time, that balance began to attract new voices. Not just scientists, but artists, filmmakers, writers, and philosophers. They saw in the WOW signal something beautiful, the idea that we had been whispered to once by the stars. And that whisper was all we had. Books were written about it. Documentaries aired across the world. Fictional stories were inspired by it. It even appeared in Hollywood, referenced subtly in movies and TV shows. One of the most iconic interpretations came in the film Contact, based on Carl Sagan's novel, where a mysterious signal from space sets off a global search for its origin. The parallels to the real WOW signal were unmistakable, a single moment of possible contact that changed everything. But behind the cultural fascination, SETI researchers continued their quiet, methodical work. They understood something the public often overlooked, that the universe doesn't repeat itself just to satisfy curiosity. If the WOW signal was real, it didn't owe us a second performance. That understanding drove SETI to keep improving their techniques. New algorithms were developed to catch short-lived signals. Observatories began collaborating globally, scanning the skies in coordinated patterns, and the search moved beyond radio. Optical SETI emerged, seeking laser bursts that could indicate high-tech communications, and still, silence. This silence, however, wasn't as discouraging as one might think. In fact, it had the opposite effect. The longer the silence endured, the more unique the WOW signal became. In a universe where data streams in endless noise, a single unexplained spike from decades ago became all the more precious. If we lived in a galaxy teeming with alien signals, the WOW signal might have been lost in the noise, but in the absence of anything else like it, it became the Rosetta Stone of the unknown. This sense of importance led to a curious shift in attitude. Even skeptics began to admit that the WOW signal, whatever it was, deserved attention. Some researchers started advocating for long-term listening projects, dedicated exclusively to the coordinates of the original signal. What if it was periodic? What if it repeated every 50 years, or even 500? Human patience rarely matches cosmic timescales. Perhaps we just haven't waited long enough. Others speculated that the signal might not have been intended for Earth at all. What if we had intercepted a transmission aimed at another world entirely? Or perhaps a data packet exchanged between two alien probes? This idea reframed the WOW signal not as a message to us, but as a cosmic eavesdrop, a moment when we happened to be listening at the right place and time. There was also the possibility that the signal was artificial, but not alien. Could it have come from a now-defunct space probe, a lost Soviet transmission, a classified US experiment? We know of many missions that were launched in the early days of space exploration, some of which went silent without explanation. Could one of them have sent out a final beacon that aligned with Big Ear's scan window? That line of thinking led down darker paths into conspiracy territory. Some fringe theories suggested the US government knew more about the signal than they let on. They pointed to budget cuts that came shortly after the discovery and the eventual dismantling of the Big Ear telescope as signs of a cover-up, but no credible evidence ever supported those claims. What remained, instead, was the enduring question: why haven't we heard anything like it since? The mystery deepened as radio telescopes became more powerful. Surely, with modern sensitivity and precision, we should have detected hundreds of WOW-like signals by now. The fact that we haven't led to a sobering possibility. Maybe the WOW signal wasn't rare because aliens are rare. Maybe it was rare because intelligent life, on a cosmic scale, is brief. Perhaps civilizations flare up like candles and die out before they ever master the art of interstellar communication. In that sense, the WOW signal could have been a message not just from the stars, but about the stars, a lesson in cosmic mortality, a silent warning wrapped in static. We were here once. Nearly 50 years have passed since that fateful night in 1977, when a radio telescope in Ohio picked up a strange signal from the constellation Sagittarius, a signal that would come to be known simply as the WOW signal. In that time, the world has changed dramatically. Our technology has advanced, our understanding of the universe has deepened, and yet the WOW signal still stands as the most tantalizing whisper from the stars, never repeated, never fully explained. But what does it mean to us now? What legacy has it left behind? For scientists, the WOW signal remains a riddle carved into the history of space exploration. It has influenced research protocols, search patterns, and how we define an intelligent signal. It taught us how to look, not just for patterns and pulses, but for anomalies. It highlighted the need for patience in a field where answers may take centuries, if they come at all. The signal is a reminder that in science, absence of proof is not proof of absence. A single unexplained moment can be more meaningful than 1,000 ordinary datasets. In recent years, astronomers have gone back to the original data, applying modern tools to reanalyze what was once measured using dot matrix printers and analog receivers. Software can now examine radio signals with more granularity, detect frequency drifts, and even identify possible patterns lost to older equipment. Yet, even with this digital hindsight, the WOW signal continues to elude definition. It matches no known astronomical phenomenon. It resembles no man-made transmission known to be in operation at that time, and still, it never repeated. This silence has taken on a kind of philosophical weight. In a universe filled with billions of galaxies, each containing billions of stars, why would we have heard just one possible signal in all this time? Some scientists argue it points to the Great Filter, the idea that intelligent civilizations might inevitably self-destruct before achieving sustained interstellar communication. If true, the WOW signal might have been a cosmic obituary, the last echo of a species that didn't survive long enough to send another. Others reject such fatalism. They argue that our current technology is still rudimentary, and our methods of listening are narrow and naive. Perhaps intelligent civilizations use quantum communication, or laser pulses, or gravitational waves. Perhaps they are deliberately avoiding contact, abiding by some form of interstellar non-interference policy, a kind of cosmic prime directive. Or maybe, they're simply not looking in our direction yet. And then, there's the more human angle. The WOW signal, in its brevity and mystery, tells us something about ourselves. It speaks to our longing to connect, to not be alone. It reveals our willingness to interpret meaning from the unknown. Even the name, WOW, wasn't scientific, but emotional. It was the handwritten reaction of a man who knew something extraordinary had just occurred. That small piece of punctuation circled in red ink might be the most human thing ever attached to a possible alien message. In this way, the WOW signal has transcended science. It has become part of our cultural language. It has inspired countless artistic interpretations, novels, films, documentaries, music, and paintings. It is often used as shorthand for mystery, the unknown, and the unexplained. In classrooms, it introduces students not just to radio astronomy, but to the emotional core of scientific discovery, the moment when data touches the soul. It has also become a rallying point for public interest in the cosmos. Organizations like SETI and Breakthrough Listen regularly use it to explain the purpose of their missions. It has helped raise funds, generate headlines, and foster global participation in the search for life beyond Earth. SETI at Home, one of the largest distributed computing projects in history, owes much of its popularity to public fascination with the WOW signal. In 2020, amateur astronomer Alberto Caballero reignited interest when he published a paper proposing that the source of the WOW signal may have been a sun-like star located 1,800 light-years away. His idea wasn't proven, but it did something more powerful. It reminded the world that the search isn't over, that the signal, even if unrepeatable, still points us somewhere. It was a direction, a moment, a guidepost, a start here from the stars. Meanwhile, the tools we use to search are becoming more advanced. The Square Kilometre Array, SKA, currently under construction in Australia and South Africa, will soon be the largest radio telescope in the world. It will scan huge portions of the sky with unprecedented sensitivity and speed. Projects like this aren't just about detecting alien signals. They're about understanding the very fabric of the universe, and yet, embedded in their mission is always the question, will we hear another wow? And so, the search continues, quietly, patiently, with millions of signals analyzed every day, and millions more dismissed as satellites, interference, or natural sources. But every now and then, astronomers remember that one signal from 1977, clear, sharp, powerful, and unexplained. It is their North Star, a reminder that the universe once whispered something to us, something strange, something possibly intelligent. Whether it was a mistake, a one-time burst from an unknown source, or a genuine extraterrestrial transmission, the wow signal has become a symbol of the unknown, a scientific relic that refuses to be buried. It speaks to the limits of our understanding and the vastness of what remains undiscovered. For the public, the story remains deeply compelling. It's the idea that we were noticed, if only for 72 seconds, that something out there, perhaps light years away, reached out. And though we never heard it again, we remember, we still listen, and we still hope. In a universe so wide and deep, even silence can be profound. It forces us to imagine, to question, to reach, and maybe that's the real message of the wow signal. Not that we heard something, but that we wanted to, because maybe the most important thing the wow signal did was teach humanity